Hi, hello guys. Welcome to Gift. Do you want to introduce yourself, state a few hobbies of yours, or do you want to get straight into your presentation?
Uh, why not? I'm Hana ElMoataz. I'm a fourth year student at the Faculty of Engineering. My major is mechanical power, and so are my colleagues Nermeen and Youssef. They are just connecting now. I will share the screen. Just 1 minute.
Yeah, we'll wait like a minute or two for the last person to join in?
Oh, no, we can see the screen, the presentation. Do you want to start?
Okay, I will start now. We are engineering students, and through our studies and projects, we visited many workshops and factories. In every place, we saw the same problem again and again. Welding is manually and not automated. Because of that, human errors cause many issues. First of all, production time is wasted, and in mass production, time equal money. Also, the accuracy is limited and not stable because each worker has a different skill level. There are also serious health risks for workers. In a study in Uganda on 327 workers in, in small welding workshops, about 87.8% of them had work-related injuries. Another study in Pakistan on 208 workers, it reported around 105 injuries in just 6 months, which is more than half of the workers. So an important question came up. Why is basic process like welding isn't automated in Egypt, which ensures safety, speed, and accuracy? The main reason is the high cost of importing robotic systems. Egypt has imported around 2,300 welding robots with a total cost of $32 million. That's where our solution comes in. At Enjad, we developed a locally manufactured 5-axis industrial robotic welding arm. It ensures high accuracy because it is automated, keeps welding quality consistent. It can be integrated into production lines to save a lot of time and has suitable price for the Egyptian market, as well as it improves safety and consistency. And since we design it from A to Z, we can easily customize it based on client needs. The robot operates by following predefined paths using coordinated movements. This allows it to execute tasks in a stable and repeatable way. It is designed to perform MIG welding operations, and we have successfully tested the movement and positioning of the system. We have also made it from mechanical joints, motors, and control unit that coordinate all movement. The control is handled using ROS2 and Arduino, allowing the robot to fully follow program paths and adapt to different tasks. This is our first working prototype. Through this version, we validated the robot movement accuracy and integration between its mechanical and control components. It represents a solid step toward building a practical industrial solution. Compared to manual welding, our robot reduces operational cost by 7% per shift and increases productivity by around 38% per shift. This makes it a more efficient and scalable option for industrial use.
Yes.
Our project aligns with several SDGs. First, quality education, as this system can be used in universities, training centers to help students gain practical experience in robotics and automation. Second, decent work and economic growth by improving workplace safety and increasing industrial productivity. Third, industry innovation and infrastructure. Since we are developing a locally manufactured technical solution that supports industrial advancement. And finally, responsible consumption and production, as our robot helps reduce material waste through precise and efficient operation. And Nermeen will continue the presentation.
Our target customers include manufacturing factories, small and medium workshops, educational and research institutions. There are groups that need automation but often can't afford high-cost imported systems. We are planning to commercialize our robot as a locally manufactured solution. Based on our cost analysis, it priced first, we have the total available market in the global welding machines, approximately about $23.75 billion in 2022, and expected to reach 34.5 billion by 23. We will first focus in the Egyptian market. Egypt has about 35,000 factory in Egypt. In 2026, they have only 2,300 imported welding robots. We will focus in a small region only in the 10th of Ramadan city. It has 7,000 factories and workshops. We have calculated the fixed cost, the variable cost per unit, the variable cost per month, and we added about 40% profit margin to be the selling price of our robot for $1,100. And we'll reach the break-even point after selling 8 units. We have several revenue streams from selling the product, renting it, maintenance and contract fees, customized part and accessories selling, training programs. All of them have a profit margin from 40 to 70%. We plan to market our project through different channels, digital and offline channels, like industry exhibitions and trade fairs. We need to show our idea in pilot programs and customer case studies and direct outreach to factories. Building this robot was a challenging but valuable experience. One of the main challenges we faced was the design of the robot itself. Each joint had to be carefully designed to achieve stable and accurate movement, since small errors could affect the entire system. We also worked on integrating this mechanical structure with the control system, which required continuous testing and multiple design iterations. We overcame these challenges by refining the design step by step, testing frequently, and improving the system based on each result. This is our team. To build this system, we need a combination of skills in mechanical design, CAD, robotics, and control systems. We worked as a multidisciplinary team to bring all these components together. Through this experience, we developed strong technical skills and also improved our ability to think critically, solve problems, and work effectively as a team. Moving forward, our next step is to complete the welding integration and test the robot in the real industrial environments. This will allow us to evaluate this performance under real working conditions and continue improving the system. Our goal is to make industrial automation more accessible, safer for workers, and practical for real-world applications. And thank you. No. Stop sharing.
All right, that's an amazing presentation. I really like the graphics in it. I'll first check the chat. We have I think 20 minutes for questions. So
I would like to ask Youssef to come onto the camera and say something. He can say it in Arabic. There you are.
You can speak English.
Oh, I can
I can speak English.
So tell us what you think about this project.
I am a technical head and operation head of the project.
Okay.
All right. So Jake, I thought this would kind of match earlier what you're saying with like how the machines are gonna be doing the work for the humans. They'll kind of lose their, you know what I mean? Previously in the AI thing. So I found the connection very funny. All right. So my question is, my first question is, do you think that do you think that the people that are being displaced by this is worth the like whole amount of metalworking efficiency there is? Because like as you said, it'll reduce labor costs, which means people will be fired. Do you think the efficiency brought on by this would be better than this than like the people that are fired?
Yeah, I think
Honestly,
okay.
okay, okay, so
Um, because the welding it's not that it's just replaced because of efficiency and consistency and business wise. No, it's also it's also very harmful to work in this environment. There are fumes, heat, sparks. Um, you don't know what else is expected. Uh,
okay.
about being fired, they will not be fired. We will like train them to work with the robot. Also, like one of the benefits of our robot is that it's user friendly. So it's like it's easier or it's easy to train the workers to use it and so on. Maybe also in the maintenance. So like there are jobs closing, but there are also other opportunities that are opened for them.
All right. Do you ever envision a time that this machine will be used like autonomously with AI rather than being trained to do things?
Yes, we uh, in the next step we are planning to use the Raspberry Pi and camera to track where to like to track the path of the welding. So yeah, to work autonomously. Yes.
We can computer vision connect with the system and develop the control system and safety of project.
All right. Jake, do you have any questions?
Yes, this is a very complicated project. Um, what was the most difficult part for you? And I'd like each one of you to answer for yourself because you all were involved in different things. So, Hana, what was the most difficult part for you?
عايز نجاوب.
I faced the control work a bit more, so it was
Yes,
hard to like we connected the electrical components, but they are not working. So it was very challenging. So like you did what you are meant to do, and things aren't working. But then we troubleshooted everything and were like detected the path step by step till we find it, me and my team.
From my point of view, we faced several problems in collecting the cost of the project. It's very cost components, the electronic components, and we are still students. And also we need to show our idea in different opportunities, and we are facing a problem in that because we are need to make more relations to do this, and we need some opportunities in this idea.
In my view, the design is very, very difficult because the limited components. The motors is very, very low torque in Egypt. We can develop this point using gearbox ratio 1 to 60, this is the point get very, very difficult. We can develop this another solution, but this big problem in my view.
Great. Good. Very good. Let me explain why I was asking about problems. Okay. I am a teacher and I have given my students projects something to do. And later I say to them, how's it going? And they said, we're done. And I said, oh, let me see it. And they said, well, it doesn't work. We're done. And that's the wrong attitude. When it doesn't work, that's when the project begins. Okay. If you're doing something and you get it to work perfectly the first time, you've wasted your time. Why are you doing something so silly and stupid? It's only problems that make a project worth doing. And so every time you run across a problem, I want you to feel happy because now you are being challenged. You are going to learn something. You are going to grow. And that's why you're doing this. So I hope in the future you have lots and lots of problems. Sid, I know you've never had any problems, but do you have a comment?
No. I mean, that was like pretty well said. We have another 12 minutes for questions.
That's okay.
So, I don't see anything on the YouTube. I think there's lag.
So I have another question. Okay. I have another question.
Okay.
Once you get this arm working, what is your next step? What are you going to do after that?
We need to make a startup and to be a company to make the automation in Egypt more affordable and low cost.
And what will you need to do that?
We need
We need support in the technical side for making this project to be a selling unit. We need to complete our process in the papers to make it as a company, and we need for sure the money.
Okay. Let me tell you a story. When I was learning to drive a car, my father told me, don't look at the front of the car as you're driving. Don't look at the front of the car. Look 100 meters ahead of the car. And I said, but wait, I don't want to hit something. He said, if you look at the front of the car and there is something there, you won't have time to react. You want to look 100 meters ahead so that if there is a problem, you have time to figure out what to do. It's the same thing with your company, okay? Don't look at the next step. Look 100 meters ahead, and try and figure out what is not the next step, but and not even the step after that, but what is 10 steps ahead. Always look far ahead. One of the things you should do right now, okay, is start to figure out if you were going to start a company, how would you do it? What the help do you need? Where would you get that support? Start thinking about the future.
We already do that, and we are planning to the next step to make this robot. To test it in industry. We already have a deal with
one of company.
New electro.
we already have a deal with the factory.
factory.
Good.
Okay. Yes, we already have a deal with the factory to test this robot in her area, and she already has imported one. We want to compare it with our robot and to do some modify after getting feedback from her, and she will buy the first selling unit.
Very good. Very good. Very good. Thinking far ahead. And after this arm, what is your next project?
I would say
CNC.
we were thinking of a CSP project. What is CSP? It's concentrated solar power plants. Yeah, some renewable energy. But let's finish this project first.
The remove.
But Hana, this project will never be finished. Okay, there's always going to be more and more and more to do. Okay,
Exactly.
but
Sad story.
even though you're going higher in this one, you also want to start to be looking at other directions you can go to. You are a team with a lot of talent, and you can do many things.
Yes.
After selling the first unit, we plan to add new features in the same item and integrate the AI systems to be more, have more features, have more safety, and we need to scale up.
So, using what you have now, the basics of a welding robot, what could you do to that welding robot to give it a whole nother range of activities? What else could that arm do besides welding?
We could
Can you
replace the end effector and put any other end effector like drilling and so on. So it's not just welding; it perform other operations.
Absolutely. That's exactly the way you want to be thinking. And then when you talk to somebody, you say, we have a welding robot, but once that's working, we can make it a painting robot or a drilling robot or a polishing robot. Okay. Many, many different things.
Yeah, we tested the movement and positioning of the robot itself. So um, the next step we add the welding machine. So our robot can be like compatible with other end effectors. Yes.
Yes, exactly. Other end effectors. Yusuf, did you want to say something?
Thanks.
We are really thankful for this opportunity.
Yep, it's an amazing slideshow. I really enjoyed the whole idea of a robot that can move in many different directions. It seems simple, but it hasn't been done yet, I think. So it's just amazing how that and how it can be applied to so many things. I just really thought its versatility was amazing. So yeah,
Thank you so much.
Jake, our next presenters here.
No, they're not. But I just want to tell the group something. Never limit your ideas to what you're doing. Okay. So for example, you've all heard of the telephone. Okay. The telephone was not invented because the person was trying to invent a telephone. They had no idea. Well, the reason they invented it was because their wife was deaf and she couldn't hear. And they were trying to invent some sort of a device which would help her hear. And so accidentally, they created the telephone and all the telephones that are around. It was not their original intention. So when you're working on a project, always think about what else could this turn into? What else could you change this into? Something else that may not have been what you were originally planning to do.
Yeah, that's actually a good mind shift to think with. I didn't know the the story behind the telephone, to be honest.
Yes, it was an accident. It was not what they were planning.
That's cool, actually.
And that happens a lot. There's many, many stories like that. That was not the original intention. It was something that came from that. And they went, oh, we can do something else with this.
Yeah.
Well, this was very good. You have any last comments? I'd like to hear a final thought from each of you. Yusuf?
Yeah. Yes, Jack.
Yes. Oh, we lost them. Well, Hana,
Yeah.
it's up to you.
Okay, I just wanted to add one more thing. We are seeking support in several key areas. Um, we want to present our team in international competitions. We need to develop the robot more, so we need technical support and mentorship. And we are also open to any internship and scholarship opportunities. And we are very glad and grateful to be here today. And thank you.
Do you have your email address or any other way people can contact you?
Yeah,
Put it up on the
where
screen.
should I write it?
We can send it in the chat of the. Okay.
Can we, if we send the emails in the chat here, will that be okay?
It will be fine. We will attach it to the video. I can't put it up on the screen.
Yeah. Okay, that's great. I'm writing mine now.
Great. I see that. Okay. Let me give you one more piece of advice. Okay. Don't be afraid to ask for help. Don't be afraid to ask people if they can support you. What you're doing is very interesting. Okay. And very valuable. And you do not have to be afraid to ask. So when you take your presentation, you should attach this contact information to it so that people anywhere can help you.
Yeah, okay.
Okay, it looks like our next presenter is here. This is great. So thank you very, very much. This is a wonderful
Thank you so
experience.
much, Jake and said.
Yeah, it was really good job, guys. It was amazing.
Thank you.